Welcome to the Tech Life Well podcast with Theo Hale and Aria Wells. Thanks for joining us. And welcome. Today we are looking at how AI and new technology impact our digital wellness, health, and overall innovation.
Yeah, it is a fascinating area.
It really is. And the big question we are tackling is, as these AI models get better, can we actually tell if something was written by a machine? Because, in the physical world, we look for a fingerprint, a distinct pattern of ridges left on a glass pane.
Right, it is definitive.
Exactly. You were there or you weren't. But stepping into digital text today, looking for an AI's fingerprint is, it is like trying to catch smoke.
It really is. It is almost impossible.
Right. So as large language models produce text that is completely indistinguishable from human writing, we are faced with this massive question. Can we reliably detect AI-generated content, or is this pursuit fundamentally flawed, easily bypassed, and prone to harmful false accusations?
And I will be taking the position that AI detection, specifically post-hoc statistical guessing, is mathematically futile against advanced evasion. It is structurally biased, and I think it gives us a highly dangerous illusion of security.
Okay, and I will argue that, while sure, early attempts at detection were flawed, a layered ecosystem of advanced statistical detection, generative watermarking, and cryptographic provenance gives us a robust, resilient framework for digital authenticity. We cannot simply surrender to synthetic spam.
But the problem with not surrendering is that, your weapons are hitting the wrong targets. The fundamental premise of post-hoc detection is mathematically flawed because the statistical distributions of human and AI text naturally overlap.
Okay, but how much do they really overlap?
A lot. And as models improve, that overlap increases, making separation basically impossible without devastating collateral damage. Relying on statistical metrics disproportionately penalizes non-native English speakers.
We definitely need to talk about that bias.
Yeah, and furthermore, any statistical signature is just trivial to evade through recursive paraphrasing. Structural solutions, like watermarking, only work in closed systems. They cannot stop bad actors from using open source models to generate untraceable text.
I completely reject the idea that we are just firing blindly, though. We are no longer relying on rudimentary pattern matching. We are seeing incredible structural advancements like Google's DeepMind's SynthID text.
Sure, but
let me just finish this thought. SynthID natively embeds statistically detectable signatures into the generation process itself. At the same time, post-hoc detectors are evolving rapidly. Turnitin now actively detects AI word spinners, identifies bypass tools, and has expanded its specialized models across multiple languages.
That sounds impressive, but is it enough?
I think it is. When combined with open standards for cryptographic provenance, we are building exactly what the National Institute of Standards and Technology recommends, which is a resilient risk management infrastructure.
Okay, let's test that resilience then. If we are going to rely on post-hoc statistical detection, we have to establish what these systems are actually measuring, because they aren't reading for soul or, creativity. They are running math.
Let's unpack the math then. The GLTR study, the Giant Language Model Test Room, gives us a perfect visualization of this mechanism. An AI fundamentally works by predicting the most likely next word.
Right, it samples from the head of a probability distribution.
Exactly. Think of language generation like driving. An AI model is programmed to be the safest driver possible. It takes the most heavily trafficked, predictable route every single time. It stays right in the middle lane.
Right, the mathematically safe choice.
Yeah. In the GLTR visualization, words in the top 10 most likely predictions are highlighted green. The top 100 are yellow. What researchers found is that AI text is just a sea of green and yellow. It is incredibly safe.
And human writing?
Authentic human writing is different. Humans are erratic drivers. We take sudden turns down scenic, unpredictable side roads. We use rare words, the tail of the distribution, which GLTR highlights in red and purple. Statisticians call this burstiness and perplexity.
Okay, I follow the analogy.
Right, so the detectors are measuring the precise absence of this human unpredictability.
But that right there is the fatal flaw of the entire detection industry. You just equated authentic human writing with erratic driving and a high unpredictability. Let's look at the Stanford HAI study. Who writes unpredictably?
Usually native speakers with expansive vocabularies.
Exactly. Native speakers with complex syntactic structures. Now, who drives safely in the middle lane? Non-native speakers. A student taking the TOEFL exam relies on standard grammatical structures and common vocabulary because they are trying to be perfectly correct in a second language.
So they stick to the rules.
Right. They do not have the linguistic luxury of taking the scenic route.
So you are arguing that their natural writing inherently mirrors the AI's probability distribution.
Exactly. It mathematically resembles AI output to the algorithm. The Stanford study proved this, showing that detectors misclassified over 61% of human-written TOEFL essays as AI-generated.
Wow, 61%.
Yeah, and a massive 97% of those essays were flagged by at least one detector. You are building an authenticity gate that treats linguistic simplicity as synthetic deception. That is a massive collateral cost.
I recognize the severity of the Stanford findings, absolutely. But we shouldn't view a detector score as a judge's gavel. Think of it as a medical screening test.
A medical test?
Yeah. When a doctor runs a screening and gets a positive result, that isn't a final diagnosis. It is a signal that warrants further human review. The industry understands the limitations of perplexity.
But do the users understand it?
Well, Turnitin explicitly acknowledges the risk of false positives against non-native speakers. To mitigate this, their system completely hides any AI detection score below 20%. They replace it with an asterisk and do not even surface it to the evaluator, precisely to protect students from those edge cases. They are calibrating the threshold rather than blindly trusting the algorithm.
I kind of think hiding scores below 20% is just a bandage on a structural wound. Even a 1% false positive rate at scale means thousands of false accusations.
It is a numbers game, sure.
Right. If you run 100,000 human essays through a system, a 1% failure rate flags 1,000 innocent people. And treating it like a medical screening assumes the sensor itself is highly robust against evasion. If post-hoc detection is our diagnostic signal, we have to admit that a bad actor can simply unplug the sensor.
You are referring to paraphrasing attacks, I assume?
I am referring to the mathematical reality established in the Sada-Savan research. The core metric here is total variation distance. When that distance shrinks, the best possible detector's accuracy fundamentally collapses.
Let's pause for a second. Total variation distance. Break that down mechanically for us. What exactly are we measuring the distance between?
We are measuring the distance between two probability distributions. Picture two overlapping bell curves.
Okay.
One curve represents the statistical signature of human text, high burstiness, lots of rare words. The other curve represents raw AI text, low perplexity, very predictable. In early models, those two curves were far apart. The total variation distance was large.
So you could easily draw a line down the middle to separate them. If it is on the left, it is AI. If it is on the right, it is human.
Right. But Sada-Savan mathematically proved that recursive paraphrasing pushes the AI curve directly into the human curve. If a bad actor uses a model to write an essay, they can just prompt it to rewrite the text with higher burstiness.
Or run it through an external tool like Quillbot.
Exactly. That process artificially injects the rare purple and red words from your GLTR example. The AI curve slides over. The total variation distance shrinks to near zero, and the distributions completely overlap. At that point, drawing a line is just blind guessing.
I see the problem there.
Yeah. Your medical screening test catches the naive 8th grader who copy-pastes directly, while completely missing the motivated spammer who takes 30 seconds to paraphrase.
It is an arms race, I won't deny that. But the defenders are mapping the terrain faster than you suggest. Let's look at Turnitin's recent technical release notes. They aren't just looking at blanket perplexity anymore.
What are they looking at then?
Well, through 2024 and 2025, they introduced interactive detection categories specifically engineered to catch evasion. They have a targeted net for AI-generated text that was AI paraphrased, and they have deployed detection specifically for AI bypasser tools.
Wait, what exactly are they detecting? If the total variation distance is shrunk, the artifact should be gone.
They aren't completely gone, though. Spinners leave structural anomalies.
They often swap in hyperspecific synonyms that destroy the natural semantic flow, creating a distinct algorithmic signature that looks neither purely human nor purely AI.
Interesting.
Yeah. Turnitin is analyzing those specific artifacts. Furthermore, they are rolling out natively trained models for Spanish and Japanese, moving away from flawed translated heuristics. They are really tightening the net.
But tightening a net made of statistical guesswork still leaves you with a guessing game. Sadasivan's point is that there is a theoretical limit to that net. When you map the artifacts of a paraphraser, the paraphraser simply updates its model to remove those artifacts.
It is back and forth.
It is a game of whack-a-mole, where the attacker always has the structural advantage because they dictate the generation. This is why post-hoc detection will always be a step behind.
Which is precisely why the debate must shift to structural solutions. I agree that post-hoc guessing has theoretical limits when dealing with sophisticated evasion. That is why we must embed the truth of the text origin at the exact moment of creation. We need to talk about generative watermarking.
I knew we would get here. Synth ID.
Yes, specifically DeepMind's Synth ID text, because it fundamentally changes the paradigm. Instead of guessing if text is AI based on general perplexity, Synth ID natively embeds a signature during the generation process using something called tournament sampling.
Hold on. A mathematical tournament for words? We need to unpack that. How does an AI run a tournament without destroying the natural flow of the sentence?
It is actually brilliant. Normally, as we discussed, the AI picks the single highest probability word from the head of the distribution.
Right, the safest option.
Exactly. With tournament sampling, the AI gathers the top tier of highly probable words, say the top 5. They all make perfect grammatical sense. Then it runs a tournament where the winner is determined by a sequence of pseudo-random numbers derived from a secret cryptographic key.
Ah, the G values.
Yes, the G values. So the model uses this cryptographic key to pick one of those top 5 words. To an outside observer, the choice seems entirely natural. Because the AI is only choosing from the top tier of words, the text retains its natural fluency.
So it doesn't degrade the text quality?
Not at all. DeepMind proved this through 20 million live interactions in Gemini. To you and me, the text reads perfectly. But to the detector holding the cryptographic key, that specific sequence of word choices glows like neon.
Okay, but calculating cryptographic terminants for every single word. Large language models are generating dozens of tokens a second. Doesn't that introduce massive latency for the user?
That was the major operational hurdle, for sure. But DeepMind solved it by integrating Synth ID with speculative sampling. Have you ever typed an email the system suggests the rest of the sentence, and you just hit tab to accept it?
Sure, autocomplete on steroids.
Right. In speculative sampling, a smaller, highly efficient draft model races ahead and predicts the next 10 words. Then, the massive, slower production model comes in behind and verifies them all at once. Synth ID runs its watermarking tournament in the background during that verification step.
Oh, wow. So the speed stays the same.
Exactly. The generation speed stays virtually identical.
Well, Synth ID is an elegant piece of computer science. I will concede that. But the deep research report explicitly outlines its fatal operational flaw. Generative watermarking requires the model provider to opt in.
True. Google Gemini participates.
But OpenAI might participate. But what about the open source ecosystem? An attacker can simply download an open source model, strip out the watermarking constraints locally, and generate endless volumes of untraceable text. You just cannot enforce a structural watermark on a decentralized system.
But does a solution need to be perfectly universal to be essential? Let me offer an analogy. A secure banking infrastructure doesn't prevent someone from trading unregulated cryptocurrency in the shadows, but we still consider secure banks to be essential baseline infrastructure.
That is fair.
Isn't structural watermarking a necessary baseline for responsible AI deployment? By securing the largest commercial platforms, the places where 99% of casual users, students, and employees interact with AI, we drastically reduce the total volume of untraceable synthetic text.
The banking analogy assumes the system is actually secure, though. The problem with structural solutions like watermarking and provenance standards is that they provide a false sense of security. Let's look at the other pillar of your layered defense, C2PA, content credentials. You attach tamper-evident cryptographic metadata directly to the file.
Exactly. It provides an airtight structural chain of custody.
I have to stop you there because applying C2PA to text reveals a fundamental misunderstanding of how we interact with words. C2PA was built for media, images, video, audio.
Sure, visual data mostly.
Right. In a photograph, the visual data and the metadata live inside a specific file container. If you manipulate the image, the cryptographic seal breaks.
Which proves it was altered. That is exactly what we want to know.
But text doesn't live in a container. Text is infinitely fluid. If a student or a spammer receives a watermarked C2PA secured essay from an AI, they don't submit the raw file container.
They just highlight it.
They highlight the text, hit copy, and paste it into a blank Google Doc. The instant that text hits the clipboard, the C2PA metadata vanishes. It is utterly useless against anyone who knows how to copy and paste.
I don't disagree that text metadata is fragile compared to an image file. That is absolutely true. But NIST's report on generative AI and synthetic content specifically champions this layered approach because they know metadata is fragile.
So they just stack weak tools?
NIST doesn't advocate for a single magic bullet. They advocate for an ecosystem, authenticating content, tracking provenance, generative watermarking, and post-hoc detection all working in concert.
A layered defense of broken tools.
No, an interlocking minefield. Think about it. If a student strips the C2PA metadata through copy-pasting, that missing metadata itself becomes a signal to the evaluator. If they use a paraphraser to strip a SynthID watermark, Turnitin's paraphraser detection catches the structural anomalies of the spinner. You layer the defenses to make evasion too costly and complex for the average user.
But layering flawed defenses just creates a thicker bureaucracy of uncertainty. Let's play out your minefield scenario. A student submits an essay. The C2PA is stripped because they copy-pasted it from their own drafting software.
Okay.
The watermarker says inconclusive. The post-hoc detector flags it as 25% AI. What does the reviewer do? They default to their own biases. And as we established with the Stanford HAI study, the statistical reality dictates that those biases will heavily penalize the non-native speaker whose writing naturally overlaps with AI distributions. The math simply does not support the level of confidence these layered ecosystems project.
We have covered incredible ground today, from the math of unpredictability to cryptographic watermarks. To summarize my position, abandoning detection entirely is effectively a surrender to a digital ecosystem flooded with synthetic spam. I concede that no single tool offers absolute, unassailable proof.
Right.
However, a risk management ecosystem that combines post-hoc statistical detection, native watermarking like SynthID text, and C2PA provenance provides highly actionable data when institutions use this data as a signal for human review, not a standalone verdict. It is a vital mechanism for preserving digital authenticity.
And to summarize my stance, the current state of detection disproportionately harms vulnerable populations. The devastating false positives against non-native writers are an ethical and mathematical failure. As large language models improve, and as evasion tactics like recursive paraphrasing remain fundamentally trivial to execute, the reality is stark.
It is a tough reality.
It is. We cannot reliably separate human and machine text through statistical guesswork, and structural solutions will always be circumvented by simple copy-pasting or open-source alternatives.
I think where we absolutely converge is on the understanding that the growing overlap between highly polished human writing and advanced AI generation is going to continually challenge our very definitions of authorship.
Completely agreed. Institutions absolutely must move away from treating detector scores as definitive proof. We have to shift toward transparent workflows that evaluate the writing process. Looking at early drafts, version history, and human comprehension, rather than relying entirely on algorithms analyzing the final product.
Remember how we started talking about the fingerprint and the smoke? A fingerprint is absolute. But as we have seen today, trying to pin down AI text is a pursuit of probabilities, overlapping bell curves, and layered defenses. The question we leave you with is this: in a world where the smoke perfectly mimics the fingerprint, how do we choose to define what is real? We appreciate you listening. Follow the Tech Life Well podcast for future episodes and updates.